input to that, it will be able to say that something it is similar to that. We'll see some example of that a little bit later. Okay. A biological neuron, it will receive signals from the dendrites, and the perceptron, that is the mathematical equivalent of that, also receives data. Okay, all this data again is processed and then it is given as an output. And like what happens in a actual biological neuron also. Here there are equivalents. It is not exactly same process that we do. Here we are equivalents. There it is electrical pulses. It is in terms of numbers. Okay. So this is basically the mathematical representation. Sir, slide, next slide, next slide.
Okay, okay, sir. Next, sir.
Next.
Next, sir.
Next போயிடுங்க. இதே தள்ளி விட்டுறேன்.
Okay.
Stop here. Okay. இல்ல இது previous slide.
Okay.
Right. இல்ல அதுக்கு previous. இல்ல அந்த பச்சை கலர் தெரியுது அது.
Oh, இதா sir. Okay.
அதான்.
Okay.
So this is a mathematical presentation of an artificial neuron. If you are good in mathematics, you can immediately see that it's a multiple regression equation. Z is equal to W1 into X1, W2 into X2 plus some B. Okay. So this is how we represent here each of that numbers, X1, X2, Xn represent inputs. We'll see what kind of input goes into a little bit later. And W1, W2 represent weights. Just remember that there is something called number inputs and there is something called weights. And plus B stands for bias. Y bias and all we'll see later. And y is equal to f of z. That z is coming as there is a function called y is the output. Okay. When you do that mathematical operation, there is some output. We represent that by y. As you see here, that y is output and the lowermost part of the equation. No? That is f is called as an activation function. It is a non-linear function. And then weighted sum of inputs is a linear combination. There you see that it is a straightforward linear combination of numbers and weights. And last term is called as a bias. Okay. Sir, at this slide. So this function called, there is some function called as an activation function. There are many types of activation functions. So depending upon the type of application, we may choose any one of them. Okay. Sigmoid function is a binary step, tan H, RELU, leaky RELU, identity. Like that, there are some mathematical functions. And one example I have shown in the bottommost part of the screen, where you see that a sigmoid function Z is represented by 1 by 1 plus that e to the power of minus Z. So when Z takes some value, when you compute a value for Z, you put it into the sigmoid function, and normally it gives a number between 0 to 1. Okay, just remember that it gives a number from 0 to 1 most of the time. There are special functions and all that we will not see, but generally it will be always either it is binary step or mostly it gives a number from 0 to 1. So next slide. This is a small example of a very small artificial neuron, where I am showing you one single neuron, artificial neuron, where we see that there are some numbers. These are the inputs. 2, 3, 1 are the inputs. 0.5, 0.2, 10 are the weight, and B, the bias value we are giving us 2. So with these numbers, if you do some calculation, that calculation what I have shown, that is 2 into 0.5 plus 3 into 0.2 plus 1 into 10 plus 2. So that will give you a value of Z is equal to 13.6. When you give that 13.6 here, 1 by 1 plus e to the power of minus 13.6, that will be output will be 0.999. Okay, that is called as a sigmoid activation function. The output is somewhere between 0 to 1. So this is the most basic artificial neuron, one single artificial neuron. Now you are seeing a little bit more expanded artificial neural network. I started calling it as a network, because here you see that now we are going beyond one. There is one input layer. There is one. Sir, next slide. Sir. Next slide. Okay. Yeah. So there is one input layer, there is something called as an hidden layer and something called as an output layer. Here you see that, as I said earlier, no, there are inputs x1, x2, x3, x4, and again every neuron here is connected to every other neuron in the hidden layer. Okay, that is the beauty. Like in our human brain, every neuron in our brain is connected to the all other neurons, billions and billions of connections. Here I am just taking a small example. A few connections are only there, but in a real brain, we are only trying to mimic what brain is actually doing. I mean, in terms of mathematics, we use mathematics to do that. Okay, so here we have some four input parameters, and we have bias neurons. There is one bias neuron, there is another bias neuron, and finally there are two activation functions here. That is called as an output layer. These three layers is the basic structure of an artificial neural network, and this is the building block for our artificial intelligence. Whatever application that that we may be using now, this is the fundamental idea behind, in whatever form it takes. Later on, we'll see that there are many representations of this kind of artificial neural network, and this is one of the most basic idea how things work. We only build on this to create more sophisticated learning models, right? So this is how it works. This is so, as I told you, no, we have to now, having created a neural network, we have to train that model, that neural network model, on that particular task, whatever task it is going to, like speech recognition. So my voice, no, it is converted into electronic signals by the mic, and that electronic signals can be processed into converted into some kind of some coding system. By that they will identify what is my tone, tenor, volume of talking, what language, I mean the kind of sound that I am making. All that will be, there are several factors which goes into understanding the voice, human voice. So those factors will be taken as input data, and then that will be fed for training this, so that next time when I go and ask Alexa, what is, how's the weather today, it will be able to recognize that I am speaking, and then it will be able to say, hello Tyagarajan, this is how the weather is going to be tomorrow or what today. That's what happens. Okay, this is the process. This is the process by which we train a neural network. So the training process happens in this kind of a cyclic process, where there is, first you take the input data, you train the next layer of the that what we see as XZF, and another layer. It goes to the next layer. Finally, it all accumulated into one single layer, and what comes out is a prediction for Y. X1, X2 leads to a prediction. But when we train, we also know when I give some value to X1 and X2, this should be the output. Again, please listen carefully. When I am training, initially when I train my neural network, I know the answer. X1, X2 is known to me, and that is the input. And I also know what is the Y that should be coming through the mathematical process. But when I train an neural network, first time it is not going to give me the correct exact value what Y is should be. Then it becomes a simple equation, and then you give input, it can, that is, calculator will do that job. Now we are talking about intelligence. So what happens is that there is a true value, but the predicted value will not be exactly the same as the true value. Okay, so there is going to be some kind of difference initially when the artificial neural network is getting trained. So it will try to find out what is, how much it is different from that. That is called as a loss function, and then a loss score generator, and we have something called as an optimizer. And then what I do is that I go back and then adjust the weights we saw in the first equation, no, x1 w1. X1 changes. Now we go back and then change W1, W2, W3 and all that. And then again do that exercise. That is called first or forward propagation. Then you compute a value, see what is the difference between actual and the predicted, and you compute a loss function. And then based on the loss function, we try to optimize the weights. Now you increase or decrease the weights accordingly. There are again a lot of mathematics involved. I'll come to that little bit later. Again, there are a lot of mathematics involved, and then that will do again a recalculation of all the weights, and then do this again forward propagation, backward propagation. This goes on for maybe 6,000, depending upon kind of model, kind of inputs, number of inputs, etc., etc. We will keep training this model till it reaches a state where the loss function is minimized. we will never ask there is something called overfitting, underfitting, and all that. That is a little bit more sophisticated understanding of ANNs. Okay, here we calculate so that it comes very, very close to the actual value. When that is happening, we say that this model is trained and ready for taking any input and then telling us, predicting mostly correctly with some little bit of error the actual output. Okay, so this is the fundamental idea behind artificial neural networks. This is an iterative process until the loss function is minimized. That word is very, very important. We never try to get the exact output which is the same as what we have computed. Be very close to that, so that at that point of time we know that the artificial intelligence neural network is capable of predicting with a little bit of error.
மீட்
Stop.
பண்ணிடுங்கம்மா. அம்மா மீட் பண்ணிடுங்க. ஓகே ஓகே perfect sir.
Okay, we keep this. Hello. The next slide, sir.
ஓகே
கொடுத்தாச்சு
Next slide,
அம்மா
sir.
மீட் பண்ணிடுங்கம்மா. லாஸ்ட்ல அட்மிட் பண்ணுங்க. மீட் பண்ணிடுங்க.
இங்க போடுக்க தலைவாணி இழுத்து இருக்கிறாரு பாரு.
Sir, next slide, sir.
சேஞ்ச் பண்ணிட்டேன் சார். நெக்ஸ்ட் சார்.
இல்ல next அதுக்கு next.
ஓகே.
So this is called as now we'll go into real application which is normally used for teaching purposes. Okay, this is called as an MNIST data set. What this data set is that you can see that numbers from 0 to 9 is there now, and it is about 70,000 handwritten images of numbers from 0 to 9 has been collected in United States of America. And these images, people handwritten numerals. Everybody have their own handwriting style, right? You can look at that. You look at the data presented on your screen, and each one of the 0 you can see how many variants. I'm only showing you about 10 numbers of that sample. So imagine there are about 70,000, how different it could have been. Okay, this is kind of a data set that I'm going to use for training for artificial intelligence system, which will be able to recognize numbers, where you can apply that knowledge. For example, you can apply that knowledge for recognizing the number plate in a car or any vehicle. Okay, whenever it comes through the camera, you can look at the number plate, and then it will be immediately tell that this car's number is something something, along with the character recognition also. That can also be done. Alphabet recognition, all that can be done. And each car have their own style of presenting that number. Some are very stylishly present. Somebody will have gold color, like that. Even though names are there, many in India at least, I don't know the audience where you're from. People use different styles, different paint, and a different way of writing and all that. So these kind of system, it is existing actually. How it is possible, made possible, is that it is because of the training that is being given to a neural network which is working behind that camera, which is sitting inside a computer and able to recognize a character. So that is one example I am trying to tell you. So what we do is that we collect those kind of data, and as I said, MNIST data set has about 70,000 handwritten images of numbers 0 to 9. We take about 60,000 of such images and then train a neural network. Like how we train is the next slide. Sir, next slide, sir. See what you see on your screen is number 4, a digital representation of number. Not digital, it's actually a handwritten version of the number 4. If you look closely, you can see that it's made up of small squares, right? That each square has got a grayscale, what is called as a grayscale. Some are really black, some are less gray, some are more gray, like that. Suppose you assume that I am giving a number from 0 to 255. Why that number 255? Because 2 power 8 is 256. When you include 0, it becomes 256. So I give a grading for each grade. Like light gray, I give some number. For dark gray, I give some number. Total black, I give 255. Final, that is a total black. And white, I give 0. So in between all these numbers, I'm actually, what I'm doing is that I'm codifying that information on my screen or handwritten 4 into some kind of a number system, which I am going to create a matrix. So next screen, sir. Yes. So you can see that for each character, I create an array of 28 by 28 numbers. You can see from the screen, it actually broken here. It will be a single line like this continuously. There are about 28 zeros on the first row, and then again 28 zeros on like that. It goes on, and suddenly after the I think at the fifth row, you see some numbers happening. Okay, that number is 189, 190. Gray scale. It is representing some gray scale. You see that some are 252 and all. It is very black. It is not so black. It is somewhere in between black and white, middle gray. And these numbers, it is tending towards black totally. 253. It is almost black. Like that, these now 60, 62 and all represented very light gray. So this is how I code that information of what I have written for 4. Like this, for every digit, I create an array of 28 by 28. Now, something handwritten has been converted into numbers. Now, you recollect our artificial neural network. Okay, here I have taken another number 2. This 2, in terms of numbers, no, is going to be represented as I told you, 0 to 255. So, here I am going to have 0 to 255 individual neurons. Okay, or perceptrons or whatever, neurons, and then feed the data as a matrix, as a number or a vector, and into this neural network. And then I'm going to have some hidden layers, which I will decide how many should be there, how many neurons should be there. Like that, there are two hidden layers, one input layer and there is another output layer. If you look at the numbers now, what it is trying to do is that it has done a prediction of p1 0.01. Like that, you see that there are numbers, but only one number here is P3 is equal to 0.950. The probability of the input that has been given is representing number 2. That is the meaning of that. Okay, this is how basic artificial neural network works. It is all mathematics. It is all coded in a different way to a computer program, through a computer program. Now I am training this neural network by showing it various numbers like what we saw in the MNIST data, and then train it with some 60,000 samples of such a data. Now the remaining 10,000, because we saw that there are 70,000 images, such images, and there are 10,000 such images, we keep it ourselves, and then what we do is that we test that neural network, how good it has been in learning that input data. So here now I do the testing and then find that 99%, 99.99%, depending upon the design of neural network, it can reach up to 99.99%. It will be able to exactly predict what is that number, what I have shown it after training. Okay, so we see that we create a neural network. It's a mathematical model, and then we have some kind of input data with which we train the neural network, and then we test the neural network. Once we are happy that it is working 99.99% is perfectly able to predict something. Here we have a working neural network, artificial neural network, which is capable of doing something intelligently. We show that number, we don't tell anything about it, we will be able to exactly tell this. You have shown me 2. See, this is a very basic example I am giving. Now we'll see what else it can do. Okay. So this is another data where you can show pictures like that, color pictures. What we have seen earlier was only black and white. Now we are going to see something. We are going to give input as something like this. So here the artificial neural network will be able to tell me what it sees, whether it is seeing a dog or a cat, or a dog and a cat together, or whatever. Okay, this is also, it is a little bit more advanced, because earlier I was having only a 28 by 28 array. Here there is something else is coming into picture, that is color. There it was black and white, here color is coming. So there you know that any color can be created with 3 colors, basic primary colors, RGB, red, green and blue. Okay, these three colors in some combination, we will be able to, millions of colors can be created out of this ratio by adjusting the ratio of RGB. So here we have 3 channels now. Now it becomes 3-dimensional. Okay, that is where we matrix. As you know, you would, as some of you would have studied mathematics, there is something called vector, there is something called matrix, and now we go into what is called as a tensor, multi-dimensional arrays. So when we go into multi-dimensional arrays, it is not easy for us to work. So we have computer programs which will do that. Okay, so mathematical functions are available which will pop up. So when you handle a color image, then it becomes a 3-dimensional array plus one more dimension is being added. And any video is actually a sequence of static images, and we make use of our what is called our eyes has a capability to 24 frames per second. No, they actually movie, when you watch the movie, actually 24 frames are going, static images are going in front of you, but you see dynamic action on the screen. There's a word I'm not able to recollect that. Okay, so that vision ability. So it is all basically static pictures, and from a video you can also whatever of interest to you by training a artificial neural network. That is what Tesla does. Tesla cars are equipped with a camera, lidar, and all that. Basically they use camera information and they label whatever that is coming in a normal road driving car. Whatever a human being is seeing, they have trained that artificial neural network that is sitting inside the car to recognize those objects, whether it is street light or a person crossing the road, a dog crossing the road, the lane, pavements, etc., etc. All those things which normally a human being is able to recognize, they have taken collected millions of such pictures and then trained that artificial neural network that is sitting inside a Tesla car, and the car has become an autonomous car, that is driverless car. That is what they call as the most sophisticated artificial neural network. So, but underlying concept, the idea behind even Tesla car artificial neural network is this. That is how they train the artificial neural network, and then they are good in doing that alone, whereas we are good in doing so many things. A Tesla car is capable of driving without driver on a road, but when you take the car and put it in a mountain, and it will not be able to drive. So there will be an accident there. Okay. So I don't know how much time you have taken. So thank you, and I can take questions from you.
Welcome, Tyagarajan sir. Vanakkam. I'm sorry I joined late a little bit, and thank you for giving this wonderful talk. And this, students, please remember, this is artificial intelligence is not just for engineering students. It affects every branch of science, including medicine, because we, as radiologists, we use it every day in our computer-assisted diagnosis programs. Cancer, breast cancer detection, lung cancer detection. So it's a very basic part of life and science anymore. No matter, even for chartered accountants, it's an important field. So every field, as you know, our CA students go for our AI classes. So it is pervasive. It's not only for engineers. And so thank you. It is a pleasure, and it's a privilege for us to have you as one of our guidance mentors for our students. And you can guide them deeper for those who are interested. Thank you so much. And I will let the students ask questions and you to answer, sir. Thank you so much.
Thank you, sir. Thank you. Thank you for this opportunity.
ஸ்டூடெண்ட்ஸ் நீங்க அன்மியூட் பண்ணிடுங்க சார், முடிச்சுட்டாங்க. ஏதாவது கொஸ்டின் இருந்தா இன்டராக்ட் பண்ணலாம்.
ஆமா, தமிழ்ல கூட கேட்கலாம், ஒன்றும் ப்ராப்ளம்.
Hi sir.
சொல்லுங்க.
என்ன மாதிரி கோர்சஸ் நம்ம வந்து இந்த ஏஐ அண்ட் எம்எல்ல வந்து அவைலபிளா இருக்கு லைக் இந்த ஆன்லைன்ல டு மாஸ்டர் ஆர் ஸ்கில்ஸ் அண்ட் ஆல்சோ வந்து இப்போ சார் சொன்ன மாதிரி இப்போ வந்து பயோடெக்னாலஜி சைடு இந்த மாதிரிலாம் வந்து ஏஐ நிறைய யூஸ் பண்றாங்க. பட் இன்ஜினியரிங் ஸ்டூடெண்ட்ஸ் இப்போ ஒரு சாஃப்ட்வேர் இன்ஜினியரிங் ஸ்டூடெண்டா இல்லை ஒரு சிஎஸ்சி பேக்ரவுண்ட் ஸ்டூடெண்டா இருந்துட்டு எப்படி சார் நம்ம அந்த ஏஐ ஆர் எம்எல் சைட்ல நம்ம ஜாப் ஆப்பர்ச்சுனிட்டிஸ் நமக்கு எப்படி சார் கிடைக்கும்? என்ன மாதிரி சார் இருக்கு இப்போ அவைலபிளா?
The job opportunities, AI, as I told you, every field it is slowly getting into every field. Like Dr. Ram has said, in medicine now, as he said, X-rays are being studied by AI systems to tell them pinpoint where exactly. Maybe human beings may miss certain things, but AI will not miss if it has been properly trained. And you are, what is your background actually?
Computer science, sir.
Computer science, it is a natural progression for you in your master's level. You can. There is no undergraduate, to my knowledge. People may say that BTech in AI and ML and all that, but that is waste actually. There is no need for, because you have to have a fundamentally. You should understand your field. If it is computer science, you'll have a broader idea about what computer science is all about. There is no point in doing at an undergraduate level specializing in AI and ML. You can do that at a master's level. You can go and do it at the master's level, and then there are many opportunities, like in medicine. You can join with the researchers who are building AI systems for medical applications. You can join for financial engineering, these kind of applications. Any field, every field is slowly, AI is getting seeping in, I would say. Slowly it is seeping into every field and every human endeavor. There is need, and people have started understanding the possibilities with the AI. AI, like a spanner, no, it is now becoming a tool in your hands. How you deploy it is up to you, but it not that you should go and do it in your BTech level or BE level. It is better you have some thorough grounding in your computer science concepts, and then from there, of course, there will be papers on AI ML in your undergraduate course itself. But if you want to seriously get into that field, then it is better to go into your postgraduate level education, where you can. Now I think IIS, IITs, many top universities are offering postgraduate level specialization in AML, where you'll be digging deeper. I only touched the very basics of artificial neural, like learning itself. Now there are now today what is very famous is reinforcement learning is coming up in a very big way. Tesla is recruiting large number of people who have been specialized in AI and ML. For example, I am telling like that. No, in India itself, in my own startup, my other partner is very good in AI and ML. I have some good knowledge only. He is excellent in AI and ML. We are building a artificial neural network for driving some robo. So there is everywhere there is going to be need for AI and ML. So computer science plus postgraduate level, or you can on your own you can study. There are a lot of courses available online where they teach basics of one very good source for all of you is that in YouTube there is something called as 3 brown 1 blue. Okay, YouTube, go and just or Google, you just go and see 3 brown 1 blue. That's the name of that YouTube channel. There they fundamentally more than what I am able to tell you. They beautifully with graphics, live graphics, they are able to explain the concepts behind artificial neural network. Okay, so that is for starters. But as a professional, you want to work in that, do something in your postgraduate level, or even after finishing your BTech, if you're good, you practice on your own. There is a lot of data sets available on open source. Data sources are available. You practice, and if you're able to convince the employer that you are very good in AI and ML, you have a very bright future. That's what I would say.
Thank you,
Clear?
sir.
Clear?
Yes, sir. Yes, sir.
அதர்ஸ் வேற யாரும் டவுட் இருந்தா கேட்கலாம்ப்பா. Any doubt?
Could you say 1 second that YouTube channel name, sir?
3 brown 1 blue.
Any others? Any doubts?
Sir, thank you, sir.
அந்த பிரீத்தி முதல்ல கேட்டாங்க சார். She is doing master degree, sir.
Okay.
யாரும் இருக்கீங்களாப்பா? டவுட்ஸ் இருக்கா? ஓகே.
Sir வந்து உங்களை is taken you to the water. He cannot make the horse drink the water. ஆனா இதுதான் future. This is whether you like it or don't like it, this is the kind of future is there. So we need to prepare ourselves. So வெக்கப்படாம find out what you need to do and please go ahead.
யாரோ ஒரு பொண்ணு கேட்டாங்க சார். ப்ரொசீட் பண்ணுங்க, கேளுங்க.
எக்ஸ்கியூஸ் மீ சார்.
சொல்லுங்கம்மா.
சார் இது இப்போ மெடிசன் சைடில் வந்து மெடிக்கல் கோடிங் அண்ட் ஆர்டிஃபிஷியல் இன்டெலிஜென்ஸ் இது ரெண்டும் ஒன்றா சார்?
இல்ல
மெடிக்கல் கோடிங் ஒன்று டெவலப் ஆகி வருது, அது படிச்சா நல்ல ஸ்கோப்னு
மெடிக்கல்
சொல்றாங்க.
கோடிங்கே வந்து கொஞ்ச நாள்ல இருக்காதுன்னு நினைக்கிறேன். As I understand, medical coding is in US, doctors dictate to the dictaphone or whatever. That data file is sent to India and people put their headphone and then listen to that and then keep typing. And the typed drafted document is sent back to the doctor. He corrects it and sends it back, and final document is finalized and it is filed. Because in US their processes are a little bit more stringent and they are litigation bound, so they are very careful about diagnosis and prescription and all that. So medical coding was a big profession in India, I know that. But what is going to happen is that now that I told you, speech recognition is one area where AI is able to do a very good job. And with that kind of development happening there, I think there will be machines which will automatically just doctor dictates and then it will give out a printout, take it and file it, or it will be digitally filed. That's all. There's no need for coming back to India overnight. It will be typed and then sent back to them. That is not going to happen in future. Maybe in another 2-3 years there won't be a field called medical coding. That's my
Correct, sir. Only connection between artificial intelligence and medical coding ரெண்டுக்கு சம்மந்தமே கிடையாது. பட் ஒன்லி கனெக்ஷன் இஸ் சார் சொன்ன மாதிரி நம்ம டிக்டேட் பண்றோம் இந்த மாதிரி டயக்னோசிஸ் ஹெடேக் அது இது டயக்னோசிஸ் ஆஃப் ஹைப்பர் டென்ஷன் அப்படின்னா அந்த வேர்ல்டு ஹைப்பர் டென்ஷனை வச்சு the computer will give the correct code with which the patient will be billed. So billing போடுறது தான் coding. Coding is not, it's a very old and very old branch. So it has nothing to do with artificial intelligence except AI, SAR Sonamari, will make coding as a course unneeded. The machine will do the coding.
ஓகே சார், தேங்க்யூ ஸோ மச் சார்.
Thank you.
இப்போ வேற யாரும் டவுட்ஸ் இருக்குதா கேட்கலாம் சார்கிட்ட. சார் வெயிட் பண்றாங்க.
சார் இப்போ வந்து என் பேர் வம்சிதரன் சார். இப்போ வந்து நான் காமர்ஸ் ஸ்ட்ரீம்ல படிச்சுட்டு இருக்கேன் சார். எனக்கு வந்து இப்போ இந்த ஆர்டிஃபிஷியல் இன்டெலிஜென்ஸ் காமர்ஸ் சார், பிகாம் சார்.
ஓ பிகாம். ஓகே ஓகே ஓகே.
எங்களுக்கு வந்து எப்படி சார் இந்த ஆர்டிஃபிஷியல் இன்டெலிஜென்ஸ்லாம்
ஸ்கோப் என்ன மாதிரி இருக்கு சார்? ஃப்ராட் டிடெக்ஷன் அக்கவுண்டிங்ல நிறைய ஃப்ராட்லாம் பண்ணுவாங்க. பேங்க்ல எல்லாம் பாத்தீங்கன்னாக்கா ஆடிட்டிங் இருக்கு இல்லையா, ஆடிட்டிங்கு இந்த மாதிரி ஏரியாஸ்லாம் ஃப்ராட் பண்ணுறதெல்லாம் வந்து நீங்கள் ட்ரெயின் பண்ணீங்கன்னா என்ன மாதிரி, ஏன்னா தெர் வில் பி a pattern somewhere. These fraudsters, no, they think that they are very smart, but if you look at it very closely, people who are experienced in auditing and all, they know where to look for what kind of information. If they are satisfied that everything is okay, then only they say that everything is good. But fraud detection is one area where AI can be very, because again it is pattern recognition. Okay, and our human brain are very good in pattern recognition. We always look for patterns everywhere. And artificial intelligence also, and artificial neural networks can be trained to look for patterns. You are able to give some data where there is an inbuilt fraud or whatever, and train the neural network, and then give any data, whether it is fraud or not, it will be able to tell that there is a possibility of fraud happening in these accounts. These kind of not only this, I'm just giving you an example. Forensics, accounting forensics, where you dig deeper into, in case you suspect that something is wrong, you do, and you can anywhere, wherever there is a possibility that there is some kind of pattern which can be trained, a neural network can be trained. There is scope for, not only in medicine or not only in engineering, not only, you can also use artificial neural network for in these fields where data is involved. and that data may be bad data, or somebody is cheating, or somebody is cooking up data. These kind of things can be caught with the artificial neural.
Sir. Thank you.
Clear?
Yes.
Any others?
Sir.
Okay.
சார் நான் பிஎஸ்சி மேத்தமெட்டிக்ஸ் படிக்கிறேங்க சார்.
Very good. Max
மேக்ஸுக்கும்
the foundation. Max the artificial neural networks sort of foundation. It stands on mathematics and particularly partial derivatives, tensor analysis. இதெல்லாம் தான் ஃபவுண்டேஷன் சார். நீ நல்லா படி, பிஎஸ்சி மேத்தமெட்டிக்ஸ் முடிச்சுட்டு நீ வந்து போஸ்ட் கிராஜுவேட் லெவலில் ஸ்பெஷலைஸ் பண்ணலாம். எம்எஸ்சி இன் ஆர்டிஃபிஷியல் நியூரல் நெட்ஒர்க்ஸ், அவன் ஏ அண்ட் எம்எல் பண்ணலாம். நீ கேட்க வந்து கேளு. நான் சரியா கேட்கல உன் கொஸ்டினை. நீ கேட்க வந்தது கேளு.
இல்லைங்க சார், பிஎஸ்சி மேத்தமெட்டிக்ஸ்க்கும் ஆர்டிஃபிஷியல் இன்டெலிஜென்ஸ் கனெக்ஷன் பண்ண முடியுமா? அதில் லிங்க் இருக்குமா?
அதை தான் சொன்னேம்மா. இப்போ அதை தான் சொன்னேன். ஆர்டிஃபிஷியல் இன்டெலிஜென்ஸோட ஃபவுண்டேஷனே வந்து மேத்தமெட்டிக்ஸ் தான். மேத்தமெட்டிக்ஸில் நீ வந்து எந்த ஏரியாவில் கான்சன்ட்ரேட் பண்ண சொல்கிறேன் உனக்கு. அதில் அந்த துறையில் நீ வந்து போகணுன்னு ஆர்வம் இருந்ததுன்னா நீ வந்து நல்லா படிக்க வேண்டிய ஏரியா வந்து வெக்டார் மேட்ரிக்ஸ் மேனிப்புலேஷன் அண்ட் டென்சார் அனாலிசிஸ், அப்புறம் வந்து பார்ஷியல் டெரிவேட்டிவ்ஸ். இதெல்லாம் வந்து இதுதான் அந்த நீ ஆக்சுவலாக போய் பார்த்தீங்கன்னா உள்ள ப்ரோக்ராம் ஆர்டிஃபிஷியல் இன்டெலிஜென்ஸ் ப்ரோக்ராம் பார்த்தீங்கன்னா இந்த மேத்தமெட்டிக்ஸ் தான் அங்கே நிறைய யூஸ் ஆகிருக்கும். ஓகே. ஸோ அதனால் வந்து பிஎஸ்சி படிக்கும்போது இதில் உனக்கு அந்த துறையில் ஆர்வம் இருந்தால் இந்த நான் சொன்ன சப்ஜெக்ட்லாம் டீப்பாக படிக்கணும்.
ஓகே. தேங்க்யூ.
ஓகேம்மா, தேங்க்யூ. நெக்ஸ்ட்
வெயிட் பண்ணுறாங்கப்பா. வேறு யாரும் டவுட்ஸ் இருந்தால் கேளுங்க.
If we can post your email address for students to contact you, is that okay?
Yeah, it's okay. Yeah, no problem.
Armu sir, can you post his email, please? Contact.
Yeah. Okay, sure, sir.
இன்னைக்கு தான் நீங்க ஃபர்ஸ்ட் டைம் யூ met ஆர்முகம் சார், ரைட் தியாகராஜன்?
ஆமாம் சார். எல்லாருமே நான் உங்களை கூட இன்னைக்கு தான் பார்க்குறேன். நான் பேசியிருக்கோம்.
சந்தோஷம். we are so fortunate. அவரு ரொம்ப கொடுத்து வச்சவங்க நம்ம ஸ்டூடெண்ட்ஸ் எல்லாம். அவர் வந்து he is dedicating his life to our students. 40 வருஷமா அவர் கவர்மெண்ட் ஸ்கூல்ல பயாலஜி டீச் பண்ணிட்டு இருக்காரு. And he has guided about 3 dozen doctors to become doctors.
Oh, excellent, sir. Excellent.
He's a gem. அவருக்கு ஆமா.
Thanks. So please your email ID, sir.
The RAJI 6307.
GI 63
RAJI Raji.
Okay, sir.
6307 RAJI.
Okay.
6307 at gmail.com.
Okay. Thanks. ஸ்டூடெண்ட்ஸ் குரூப்ல போஸ்ட் பண்ணிடுறேன் சார். அவங்க ஏதாவது டவுட்ஸ் இருந்தால் உங்களுக்கு மெயில் பண்ணிட்டு.
கரெக்டா கேட்குறேன்.
சார்
கேளுங்கப்பா.
சார் ஏதாச்சும் அட்வான்ஸ் லெவல் ஏஐ டுட்டோரியல்ஸ் இருக்கா சார்?
அட்வான்ஸ்டு ஏஐ டுட்டோரியல்ஸ் வந்து யூனிவர்சிட்டி எம்ஐடிலாம் இருக்கு இல்லைங்களா? எம்ஐடி மாசச்சூசெட்ஸ் இன்ஸ்டிடியூட் ஆஃப் டெக்னாலஜி யூஎஸ்ஏ, அப்புறம் கால்டெக், இவங்களும் வந்து நிறைய லெக்சர்ஸ் எல்லாம் வந்து போட்டிருக்காங்க யூடியூப்ல. நீங்க போய் டைப் பண்ணீங்கனால எம்ஐடியும் சேர்த்து விட்டுருங்க. அதில் எம்ஐடி அப்படின்னு போடுங்க. இல்லைன்னா ஸ்டான்ஃபோர்ட் யூனிவர்சிட்டியோட ஓப்பன் கோர்ஸ் வேர்லாம் இருக்கு.
ஓகே.
அதெல்லாம் ப்ரொஃபசர்ஸ், அங்கே இருக்கிற டாப் ப்ரொஃபசர்ஸ் வந்து ஃப்ரீயாக லெக்சர்ஸ் எல்லாம் கொடுத்துருக்காங்க. இந்த சப்ஜெக்ட்ல வந்து பேசிக்ஸ்லேருந்து அட்வான்ஸ்ட் வரலாம் கொடுத்துருக்காங்க. தெர் ஆர் சம் வெரி பாப்புலர் கைஸ் ஹூ ஒர்க்ட் இன் டெஸ்லா, அந்த மாதிரி அவங்கெல்லாம் கூட வந்து லெக்சர்ஸ் கொடுத்துருக்காங்க. அதெல்லாம் கூட வந்து நெட்வொர்க்ல இதில் இருக்கு. நீங்கள் ஒரு இமெயில் எனக்கு அனுப்பி விடுங்க. நான் உங்களுக்கு அந்த பேரெல்லாம் அனுப்பி விடுறேன். அதெல்லாம் கொஞ்சம் வாயில நுழையாத மாதிரி இருக்கும் பேர்லாம். நான் எக்ஸாக்ட் நேம்ஸ் ஆகிடுங்க.
ஓகே, தேங்க்ஸ்.
தம்பி செந்தில் முருகன் வந்து மதுரை தியாகராஜா காலேஜ் ஸ்டூடெண்ட் சார்.
அப்படிங்களா? ஓகே.
டிவைஸ் எல்லாமே உருவாக்கி டெமோ பண்ணினார் லாஸ்ட் சீட்ஸ் கனெக்ட் ஈவென்ட்ல.
என்ன பண்ணாரு? என்ன டெமோ?
செந்தில் கொஞ்சம் எக்ஸ்பிளைன் பண்ண முடியுமா சார் கிட்ட?
எஸ் சார். சார் அந்த டிவைஸ் வந்து ஸ்மார்ட் வீல் சேர் சார். அது ஆட்டோமேட்டிக்கா எஸ். அது வந்து பெட்டு சேர் வந்து அது அதுவாகவே மாத்திக்கிற மாதிரி பண்ணிருந்தேன் சார். அதோட ஸ்டேட் வந்து சேஞ்ச் பண்ணிக்கிற மாதிரி பண்ணிருந்தேன் சார்.
ஓ ஐ சி. ஓகே ஓகே ஓகே. ஸோ என்ன சென்சார்ஸ்லாம் யூஸ் பண்ணீங்க?
சென்சார்ஸ் கம்மியாக தான் சார் யூஸ் பண்ணியிருந்தேன். இன்னும் கொஞ்சம் அட்வான்ஸ் பண்ண வேண்டியது இருக்குது சார். அதான் கொஞ்சம் ஏஐ அல்காரிதம்ஸ் அதில் யூஸ் பண்ணி நிறையா பண்ணலாட்டு இருந்தேன் சார். மெடிக்கல் சம்மந்தப்பட்டதான் இன்னும் ஃபீட் பண்ண வேண்டியது இருக்குது சார். அதான் சார்.
ஓகே சார். இல்லை சென்சார்ஸ் பற்றி நீங்கள் நிறைய தெரிஞ்சுக்கணும். ஏன்னா அதுதான் நம்ம ஏஐ நீங்கள் பில்ட் பண்ணிடலாம். அது கம்ப்யூட்டரில் உட்காந்து இருக்கும். பட் அது வர டேட்டா நல்ல குவாலிட்டி இருந்தால் தான் உங்களுக்கு ஒரு அவுட்புட் நல்லா இருக்கும். அதனால் நீங்கள் வந்து என்னென்ன சென்சார்ஸ் எல்லாம் இருக்குதுன்றதை பற்றி முதல்ல நிறைய தெரிஞ்சுக்கணும். அது என்ன மாதிரி ஒர்க் பண்ணுதுன்னு தெரியணும். அதுலேருந்து என்ன அவுட்புட் வருது, அந்த டேட்டாவை நம்ம எப்படி ஏஐக்கு ட்ரெயின் பண்ணுறது எடுக்கலாம். இதெல்லாம் வந்து அந்த பைப்லைன் இருக்கணும். இல்லைன்னா போட்டு கார்பேஜ் இன் கார்பேஜ் அவுட் அதான் நடக்கும் ஏஐல.
ஓகே ஓகே
ஓகே.
வேற யாரும் டவுட்ஸ் இல்லை கேளுங்கப்பா. எனி டவுட்ஸ்? வைண்ட் அப் பண்ணிடலாமா?
சார் பண்ணிடலாங்க.
ஓகே.
தேங்க்ஸ்
சார்.
Go ahead, sir. Armand, sir, go ahead, please.
ஓகே சார். வெவ்வேறு பிளாட்ஃபார்ம்ல இருக்கிறாங்க. ஆர்ட்ஸ் அண்ட் சயின்ஸ் டிப்ளமோ ஹோல்டர்ஸ், என்ஜினியரிங், மெடிசன். அதுதான் அவங்க இப்போ எப்படி அப்ளை பண்ணலாம். பட் உங்களோட செஷன் ரொம்ப இன்ட்ரெஸ்டிங்காக இருந்தது. எல்லாருமே யூஸ் பண்ணிப்பாங்க. ஃபர்தர் உங்களோட மெயிலில் நாங்கள் மெசேஜ் பண்ண சொல்கிறோம் சார்.
சரிங்க, நன்றி.
வெவ்வேறு டைட்டில் நீங்கள் எங்கள் ஸ்டூடெண்ட்ஸுக்கு அக்கேஷனலாக ஒரு ட்ரெயின் பண்ணிவிடுங்க சார். தேங்க்ஃபுல் சார். ஆன் பிஹாவ் ஆஃப் சீட்ஸ் உங்களோட டைமுக்கு நாங்கள் ஹெல்ப் பண்ணிக்கிறோம். தேங்க்யூ சார்.
தேங்க்யூ வெரி மச்.
Thank you so much, sir. We are blessed. Thank you.
Thank you, Mr. Armand.
Students make good use of everything. Thank you.
Thank you. Bye.
Thank you so much, sir.